Okay, in today's tutorial, we will be trying this repository called Image Super Resolution from IDLO. I'm not sure if that's the correct way to pronounce it, but yes, Image Super Resolution. So what this project does is this repository provides number of super resolution models, but we won't go through the details of each model. Uh, so what this does is it takes the model in this repository, takes an low resolution image as an input, and it outputs a higher resolution image as shown in the right. So what I'm going to do is I've collected food images from the internet, and they are of low resolution. So what we're going to do is use this project to change these low resolution images to high resolution. So yeah, we could do this using a Photoshop, but if there are like hundred images, it's going to be time consuming to run to change each of the image to higher resolution. So that's going to take much time if we use Photoshop. So what we can do is use this project to process each image. We could just make a script to let the model process each image in the folder. So first, let's clone this repository. Copy that, and let's open up a terminal right here. Let's make that a bit bigger. Okay, let's clone this. Git clone. And we have cloned the project. And first, let's move that food images to the project folder. Image super resolution. It's in there now. So let's go into that project. And before we continue, let's first create a virtual environment just to be safe. Python 3.8, virtual environment. We have made it right here, and let's activate that. There, activated. Next step, let's follow the instructions. Skip the model explaining part, and let's go to installation. In order to install this project, there are two options. One is to use pip, but I'm not going to use pip because I've already cloned the repository. So I've cloned this repository. I am inside the project folder, and let's install it by running this line of code. Let's just copy that, paste it, and let's run it. Okay, so if we run this code, then this is going to install dependencies, libraries needed to run this project. However, if you see here, it's going to install TensorFlow 2.7 by default. But on my device, it's not able to run TensorFlow 2.7. So what I'm going to do is, once this installation finishes, I'm going to uninstall TensorFlow 2.7 and install the right version of TensorFlow for my device, which is TensorFlow 2.3. So let's first uninstall TensorFlow. If we do that, it's going to uninstall TensorFlow, and I'm going to install another version, which is 2.3.0. That's for my device. And for those who are following this tutorial, I suggest you look for a right TensorFlow version to run this project. Okay, I'm just going to install that. Shouldn't take long. Okay. Once this is installed, let's wait a bit. Okay, it's uninstalling TensorFlow 2.7 first. Okay, it's installed, so everything's ready now. So let's now create a file to process low resolution images. I'm going to call it process.py, and let's make this a bit bigger. And I'm just going to follow the code in the repository. So it's under usage. It says here, in order to use this model, we need to first load an image, prepare it, and use the model to change the low resolution image to higher resolution. So let's just follow that step by step. So let's first import NumPy and import pill image as well. From pill import image. Let's first, for now, let's just consider one image first. So image open. I'm just going to put a dummy path. You don't have the dummy PNG image, but I'm just going to put it there just for now. And before we convert it to, so this right here, right now, is a pill image, but we need to convert it to low resolution image of type NumPy array, like this. But before doing that, just to be safe, let's have this line of code that converts this image to RGB format. Convert to RGB. So that's going to change red image to RGB. And then now we're going to change it to LR image of type NumPy array. Now that we have this low resolution image, we need to initialize the model. So this block of code does that, and let's first read this from ISR models import RDN. There are other models as well, RRDN, but we're just going to use RDN for this tutorial. And let's initialize the model in this line of code before reading the image. So RDN equals RDN weights. It says here PSNR small, but there are other options as well, like PSNR large or noise cancel. So PSNR large is just a larger version of PSNR, and PSNR small is the smaller one compared to this large. And noise cancel is a model that removes pixel noise in an image. So for now, let's just stick to PSNR small. Now that we have this initialized model, we are going to feed this LR image to RDN model. So we are going to do that by following this line of code right here. Okay, SR image equals RDN predict LR image. So that is going to run this model and change this LR image to SR image. That's of type NumPy array as well. So if you want to save that into a new file name, we have to first change that to a PIL image format. So we do that by, I'm just going to use the same name, image from array SR image. It's just the same as this line of code right here. And once we have that PIL image, we can now save it. Image, just going to use the same name. Save it to a file name called result.png. Okay, so this block of code now is going to initialize the model, read an input image, then make an inference, and save this new image into this file name called result.png. And we are going to save that and close it. Let's try to run if it works. Python 3.8 process.py. Then if this runs, oh, we don't have dummy.png, so let's just change that to some image that we have in food images folder. So food images, let's try the first image, which is, what's this? Image of cherries. So 0030.p, it's not PNG, it's JPG. Let's just remove that. Save it, close it, and let's run it again. So the model is going to take this small image and output a new file, but there's an error again. Oh, the file names, I should have said 0030. Okay, let's just change that again. 0030. Save it and close it. Let's run it again. So this right here is the original image, and it finished running, and we have now here a new file. As we can see, the size of an image is double the size of the original image. Original image size was 219 by 325, but the new file is of size 438 by 650, and we can see as the result, if we zoom in, I think if the edge is a bit crispier. Yeah. So also this region looks better on the right. Yeah. So that's PSNR small model. Now, instead of processing one image, we want this code to process all the images in this food images folder and save it into some other folder. So we will do that by first calling from glob import glob. Not sure if that's the right way to call it, but I'm just going to use it. So we are just going to initialize the model here. Glob, read the files. So root folder name is food images, which is here. Food images, and read all the images in this folder. So that's going to be saved here. Image paths. This is going to return a list of image paths. Now that we have that, we're going to process each image path. Okay, now just going to make an indentation right here. Instead of this one file, now it's going to take an image path, and everything stays the same, except now here we have to create a path to save this new image into a new folder. So I want a new folder name called first image save path equals image path replace food images. This food images text will be replaced to HR food images. Now that stands for high resolution food images. And okay, and now we are going to save this new image into image save path. But we don't have this HR food images folder, so we are going to manually create one here. There, it's currently empty, but if we run this code, hopefully all the food images here, low resolution food images, will be processed and the new result will be saved in this folder. Let's try to run this code. Save it first and run this code. If you run it, before running it, just cancel that, just to see if each image is processed correctly. I'm just going to say print processing file path. If we have that, save it, then when we run this code, we will be able to see which image is being processed right now. So as we can see, the code is running with no errors. So it's processing each food image in this food images folder, and if we go into HR food images, it's processing. This is a new image processed by the model. So let's see, this is the result, and let's check if there's a difference. So this is the input to the image, and this is the output. If we zoom in, I guess we'll be able to see the difference. If you see here, it's the input image on the left is a lot blurry compared to the one in the right. So it's working. Yes. Okay, we could use this code like this, but we could also, if we go to the repository, it says here we could use this model by providing a parameter called by patch size of 50. So if we have that, I'm just going to type it in here, by patch size of 50. So what this is going to do is, instead of, when given this, oh, it shouldn't be here, it should be right here, size of 50. So what this does is, given low resolution image, if we don't have this parameter, it's going to take this LR image as a whole and feed it to the RDN model. But if we have this parameter by patch size of 50, what this is going to do is, instead of feeding this image as a whole to the network, it's going to use patches to process this image. So instead of feeding this image as a whole, it's going to input a small patch to the model, like let's say of this size, and next patch is going to be of this size as well. And then, like, after processing each batch and covering the whole region of an image, it's going to assemble back to the original image. And yeah, so basically it's processing the model by patch, image patch. So by doing this, it will hopefully produce better results. So if we have this parameter, save it, close it. If we run it, by patch size of, okay, maybe the name's a bit different. So let's go to by patch, oh, by patch of size, not size of. So it should be like this. And let's just save this into a new file name, folder name called HR Food Images patch 50. And since we don't have that folder name, let's go back, create new folder, HR Food Images patch 50. Save it, close it, and if you run the code, new images will be saved in this folder. So I think the result's not going to be that different, but I'm just showing that you could use this code like this. Yeah. So yeah, the result is a lot bigger than the original image, and the quality should be better too. And yeah, so that's another way to use this model. Let's just cancel that. And lastly, I'm just going to show you, instead of using PSNR small or PSNR large, we could also use noise cancel. And just going to remove this by patch size of 50. Just going to leave it like that. And let's use another output folder name, noise cancel, and create one again manually. You can change it to create a folder automatically later, but just for this tutorial I'm just going to manually create the folders. Food images, noise cancel. We have that. What this is going to do is now, instead of, well, basically does the same thing, I think, but it removes pixel noise in an image. So food images. Let's look for an image that has lots of noise in it. Let's see. Most of them looks clean. Let's just run it and check some of the examples. Save it and close it. Let's run the code. This version should be a lot slower than other models like PSNR small or PSNR large. So you can see it's a bit slower processing one image. So let's compare it with this one, the PSNR small and without the patch. So what was the name of the file that I want to see? 303. Does it have 303 here? Doesn't. So let's just compare it with this version. 303. So this is on the left is when using PSNR small with patch size of 50, and this new one is when using noise cancel with patch size, patch parameters 0. So if we see here, the noise level is this region. If we see the difference, it's a lot cleaner than the one on the left. So I guess noise cancel version actually really removes the noise in the image. Let's see other regions as well. Let's try to see. Let's just look another image. Let's see. 4122. Nope, this is too big. Pumpkin. Let's see this pumpkin. 4059, and let's go to patch 50 results. 4059. There we have a pumpkin. So on the left is PSNR small with patch size 50, and on the right is the noise cancel. If we see, let's zoom in. Image size is the same, I think. But if we zoom in, I think the result on the right is a bit more cleaner. See here, we see some artifacts in this edge region, but we cannot see them in the right sample right here. So I guess noise cancel version, I think if I were to use this model, I'm going to use this noise cancel. It's a bit slower compared to PSNR small, but the quality of the image is a lot better. So I think I'm going to go with this model. Yeah. Yeah. So if I'm just going to cancel that. Okay. So using this code, these lines of code, you can process all the images in this low resolution images, and if you just run this code, you can save the new results into a new folder. You just have to wait for a few minutes, I guess. So yeah, so using this project, you can process multiple images. You don't have to use like Photoshop to process each image to high resolution. Yeah. Yeah, so that's all for today's tutorial. I'll come back with another interesting project next time.